In 1957, astronomers at the Tonantzintla Observatory in Mexico would catalog what they believed was a blue star. But in 1970, scientists noticed that it didn't behave like a star or have the chemical composition of one. It belonged to a newly discovered class of objects called quasars, and not just any quasar. It would be a quasar with what might be the largest black hole ever discovered. Before diving into what makes this object so interesting, it's worth covering what a black hole is and what it isn't. Black holes form when matter gets compressed into space so small that the force of gravity becomes so overwhelming that not even light can escape. Surrounding the black hole is something called the event horizon. This is basically a one-way street. Once you go in, you can't get back out. If you were to take the sun and compress it down to around 6 kilometers across, it would form a black hole with one solar mass. Contrary to popular belief, black holes don't act like vacuum cleaners, sucking everything up. Even feeding a black hole is difficult. Gas and dust don't like to fall neatly. They accelerate to a significant percentage of the speed of light and form a plasma that surrounds the black hole and creates the accretion disk. Outside of the event horizon, a black hole acts like any other gravitational object. If you replace the sun with that one solar mass black hole, the orbits in the solar system would stay the same, although things would be much colder. For over a decade, TON 618 was catalogued as a star and was largely ignored. It wasn't until astronomers started taking a closer look at objects similar to it that things got interesting. Scientists get a lot of their information purely from light. Looking at the spectrum of light can tell you things about an object's chemical composition and age. But when looking at TON 618, its chemical composition wasn't what they expected from a star, and everything was shifted red. In an expanding universe, the further away something is, the more its light gets stretched toward the red. The light they were looking at was so redshifted, it was estimated to have been traveling for around 10.8 billion years. But from that distance, it couldn't be a star. It outshines entire galaxies. So what was it? Objects like this eventually came to be known as quasars. They're the most luminous sustained objects in the universe. Gas forms an accretion disk around the black hole. If you've watched Interstellar, you know exactly what that looks like. And matter from the accretion disk gets accelerated to a significant percentage of the speed of light. As everything collides, it begins to heat up to tens of thousands of degrees and eventually outshines its own host galaxy, the brightness of hundreds of billions of stars. But this light isn't the black hole itself. It's basically the goodbye message of the matter falling into the black hole. So how do we weigh something that we can't directly look at? You simply watch the stuff around it. That cloud of gas around the black hole is orbiting at a mind-boggling speed. The light from the gas moving towards us is compressed, and the light from the gas moving away from us gets stretched out. Because of this, when looking at the light, it gets smeared, and the broader the smear, the faster the orbit. This, along with a reasonable estimate of how far out the gas is, gives you the mass at the center. It's not perfect, but for something that's literally across the universe, we'll take whatever we can get. In 2004, astronomers estimated the mass of TON 618, and it came in at 66 billion solar masses, 66 billion times the mass of our sun. In 2019, they used better methods and got an estimate of 40 billion solar masses. While that may seem like a huge difference, even at the lower estimate, it would still be one of the most massive black holes in the universe. Ultramassive black holes are black holes above 10 billion solar masses, and this one fits comfortably inside that category. For comparison, Sagittarius A star is the black hole at the center of our galaxy, and it's only 4 million solar masses. TON 618 is 10,000 times heavier. Numbers don't do it justice. The black hole's event horizon grows in proportion to its mass, and at 40 billion solar masses, if you swapped it with the sun, it would extend out almost 5 times further than where Voyager 1 is right now. Even the animation you're watching on screen right now can't properly capture the scale of how massive it is. It's so wide that light, moving as fast as the universe permits, would still take over a week to cross it. Over a week for a single object. The accretion disk has the output of over 100 trillion suns, thousands of galaxies worth of light from one gas cloud doomed in the black hole's orbit. But despite its extreme nature, it doesn't cause chaos, at least on a cosmic scale. Everything around it is in a stable orbit, has billions of stars orbiting it, trillions of planets. From a distance, it doesn't bother anyone. There is a problem that we touched on briefly. Black holes don't like getting too big. But how did TON 618 get so big? The light we're seeing is 10.8 billion years old. That's from early in the universe, and this black hole already had tens of billions of solar masses. It would have to swallow 10 suns worth of matter every year since the Big Bang without stopping. But the accretion disk heats up, and the radiation from it pushes on everything behind it. A black hole can't consume matter too quickly. Scientists call this the Eddington limit. TON 618 appears to have broken this limit. It may have never started small at all. Perhaps it formed from a vast gas cloud early in the universe, or it was the result of massive black hole mergers. Either way, we'll likely never know. It will be one of those cosmic mysteries that will linger simply because we were around to observe it. And if you've spent any time in this corner of the internet, I'm sure you're asking, what about Phoenix A? Doesn't it have the mass of 100 billion suns? Wouldn't that make it the biggest? And the answer is maybe, but nobody can actually say. Unlike TON 618, Phoenix A has never been measured. The figure that got propagated all over the internet was from a theoretical model of the galaxy cluster it sits in. It's an inference of what could be there, not an actual measurement. Scientists haven't been able to measure the gas or stars around it, so that's why it doesn't hold an official title. In 2025, astronomers discovered a black hole with 36 billion solar masses in the cosmic horseshoe galaxy. It was measured from the motion of its stars and the light bending around it. This is also being labeled as one of the most massive black holes ever reliably detected. And reliably is the keyword here. Even TON 618 has massive uncertainty when it comes to its estimate. The uncertainty on Phoenix A is even larger. What we can say is that TON 618 is the most massive black hole we've estimated from the object's direct surroundings, and that's a good place to end things. It's simply impossible to know for certain. TON 618 could be billions of suns more massive now, or it could have stopped feeding altogether and gone dormant. But this will remain a mystery, much like how its formation was a mystery. What we're seeing now is a brief snapshot from when the universe was very young and much more violent. If you like this video, it would mean a lot to me if you hit the like and subscribe button. You can support us further on Patreon for early access to content, voting on future topics, and Patreon exclusive videos.